Next topic, we are discussing about application of Schrodinger wave equation to a particle in a one-dimensional infinite potential well or box. Particle in a one-dimensional infinite potential well or box. Consider a particle of mass small m. Consider a particle of mass small m. The particle moving back and forth between the walls. The particle moving back and forth between the walls of a one-dimensional box separated by a distance a as shown in figure. Let the particle travels only along the x-axis. Particle travels only along the x-axis and is confined between x is equal to 0 and a by two infinite hard walls, that it does not lose energy when it collides with walls. Thus it does not lose energy when it collides with walls, and its total energy remains constant, so that the potential energy of the particle is infinitely high on both sides of the box. The potential energy of the particle is infinitely high on both sides of the box, and inside V is uniform. Potential energy is uniform. Let us assume potential energy V is equal to 0 inside the box. Let us assume that potential energy V is equal to 0 inside the box. We can observe the boundary condition. X is equal to 0. V of x is equal to 0 for 0 less than x less than a. V of x is equal to 0 for 0 less than x less than a. 0 less than x less than a. V of x is equal to 0. And V of x is equal to infinity. V of x is equal to infinity for x less than 0 and x greater than a. V of x is equal to infinity for x less than 0 and x greater than a. X greater than a. Then the wave function psi. Then the wave function psi of the particle in the region 0 less than x less than a. We know that where V is equal to 0, where V is equal to 0 means potential energy value is taken is 0. That V is equal to 0 is substituted in Schrodinger equation. We get d square psi by dx square sum of 8 pi square m by h square is psi is equal to 0. This is Schrodinger equation. Schrodinger equation V is equal to 0. Potential energy V is equal to 0 is taken as Schrodinger equation. We get this equation. This is compared with k square psi. Both are compared where k square is equal to 8 pi square m by h square e psi. K square is equal to 8 pi square m e by h square. The solution of this equation 2 is psi of x is equal to a sin kx plus b cos kx, where a and b are arbitrary constants. The solution of the above equation is psi of x is equal to a sin kx plus b cos kx, where a and b are arbitrary constants. Applying first boundary condition, that is x is equal to 0. When x is equal to 0, psi of x is equal to 0. Sin 0, 0. X value is 0. Substitute, we can get sin 0, 0. Then b is equal to 0. X is equal to 0. Psi of x is equal to 0. X is equal to 0 value, substitute sin 0, 0. Then we can get b is equal to 0. We get b is equal to 0. Just applying the second boundary condition, that is x is equal to a. X is equal to a. Psi of x is equal to psi of a is equal to 0 is substitute. Psi of x, psi of a is equal to 0, substitute 0 is equal to a sin ka. B value is already substitute 0. B value is 0. Psi of x is equal to psi of a is equal to 0. 0 is equal to a sin ka. X plus we can substitute a. B value is 0. 0 is equal to a sin ka. Ka is equal to n pi. K is equal to n pi by a. But k square is equal to n square pi square by a square. K square is equal to n square pi square by a square, where n is equal to 1, 2, 3 and so on. We can take this k square value and this k square value. That means Equation 3 and 4 compare this equation, both k square, this k square value and this k square value. Compare these two equations. That means equation 3 and 4. 8 pi square me by h square. 8 pi square me by h square is equal to n square pi square by a square. Both are compared. You can get 8 pi square me by h square is equal to n square pi square by a square. To compare these two equations, we can get then E is equal to n square pi square h square by 8 pi square m a square. Pi square is cancelled. Then E is equal to n square h square by 8m a square. Then N is equal to n square h square by 8m a square. The lowest energy of the particle. The lowest energy of the particle is obtained by putting n is equal to 1. N is equal to 1 we can substitute, then we get E1 is equal, when n is equal to 1 we can substitute h square by 8m a square. N is equal to 2 we can substitute. E2 is equal to 4 pi square. 4 n put the place we can substitute 2 square means 4 h square by 8m a square. 4 h square by 8m a square. N is equal to 3 we can substitute 9h square by 8m a square. Similarly E4 is equal to 16 into E1. Here we can substitute E2 is equal to, this value is E1. E2 is equal to 4E1. E3 is equal to 9E1. Similarly E4 is equal to 16E1. This energy level diagram of a particle in one dimensional box. For n is equal to 1, E1. N is equal to 1, that is equal to E1. N is equal to 2, 4 into E1. N is equal to 2, 4 into E1. For n is equal to 3, 9 into E1. For n is equal to 4, 16 E1. You can get, for n is equal to 1, n is equal to 1, E1. N is equal to 1, E1. N is equal to 2, 4 E1. N is equal to 2, 4 E1. N equal to 3, 9 E1. N equal to 4, 16 E1. N equal to 4, 16 E1. This is the energy level diagram of a particle in one dimensional box. The wave functions psi1 and psi2 and psi3 corresponding to n is equal to 1, 2, 3 and so on. The wave functions psi1, psi2 and psi3 are corresponding to n is equal to 1, 2, 3 and so on are shown in figure. For n is equal to 1, the wave function psi1. For n is equal to 1, the wave function psi1. It has only two nodes. For n is equal to 1, the wave function psi1, it having two nodes. One is x is equal to 0, another one is x is equal to a. The wave function psi1, n is equal to 1, it having two nodes, x is equal to 0 and x is equal to a. For n is equal to 2, the wave function psi2, it having three nodes, at x is equal to 0, x is equal to a by 2, x is equal to a. For n is equal to 2, the wave function psi2 has three nodes. N is equal to 1 has two nodes, n is equal to 2 has three nodes, that are 0, a by 2, a. For n is equal to 3, the wave function psi3 has four nodes. The wave function psi3 has four nodes, that is 0, a by 3, 2a by 3, a. Therefore we can get, for n value, we can get n plus 1 nodes. For n is equal to 1, 2 nodes, n is equal to 2, 3 nodes, n is equal to 3, 4 nodes. Therefore the wave function psi n is equal to n plus 1 nodes. This is about Schrodinger one dimensional time independent wave equations we are discussing. Time dependent we can discussing. According to our syllabus, we are discussing about particle in a one dimensional potential box. If you like this video, please subscribe. Thank you.